Alright guys, so welcome to the second part of Coding 101. So in today's session, we're going to be going over getting to know Introduction to Code. However, before we begin that, I'm just going to take about 2 minutes, make sure everyone gets into a room and is all set up. Some quick things to just have handy are your Arduino kit, which should have your Arduino, maybe get the breadboard out, your jumper wires or jumper cables, your resistors, and then one LED. Color for the LED does not really matter. Okay, so I'm gonna give you guys about 2 minutes. All right, so we're gonna go ahead and get started. So like I said, this is part 2 of Coding 101. So we're gonna be going over getting to know the introduction of code and then the basic functions. So prototyping our device, our project. And our first project is actually going to be the SOS emergency code system. So we'll get more into that later. So like I said, it might be helpful to have out your Arduino or LED board, depending on what you're using. I have the Uno. However, there are different variations. I will be using the Uno. However, if you don't have the Uno, that's fine. Your only difference might be that you might be using a different port. The next thing you're going to have out is your LED. Color does not matter. Your resistors. I have them 2 here. And we'll be going over how to read them. So if you're not sure which one we're going to be using, no worries. All your jumper cables. So these are literally just wires that you will use to connect your different devices together, and a breadboard. And we'll be going over how to read a breadboard. All right, so let's get started. Like I said, the first thing, this is a slide from last week. Our main thing that we're going to be programming is Arduino, and this will be literally our brain for the entire machine or project that we're doing in this class. Right, so first things first, let's identify our problem. So we're going to be building a SOS system. So there are some hardware and software solutions that you need. So our hardware will be actually all the Arduino, LEDs, resistors, wires, any device, physical item that we're going to be using to build this project. And then the software will be the Arduino platform. There are 4 steps. So first thing first is identifying the hardware requirements. Second step is identifying and deconstructing the code elements. So basically, like I said, code cannot be like, hey, grab me a glass of water. It has to be broken down to like get up, walk 10 feet, etc. Step 3 is going to be constructing our hardware. So putting all of our hardware together now that we know what our requirements are. And finally, step 4, writing the code. Right. So quickly going over the Arduino Anatomy. So we have some ports on top. These will be our digital ports. Some ports on the bottom. These are our power and analog ports. So digital devices such as screens or displays, anything like that would be plugged up here. Then we get into power. So anything we'll be utilizing such as motors and stuff will go down here. And then finally, we have the analog, which will be kind of like digital. However, it is a little different. We will not be using analog today. We will be primarily preferring on the power because it will be powering the LED. Right. Also, it has a USB slot, and then it also has a power slot. The power slot is after you enter your code into the Arduino, and if you do not erase it, then you can actually plug this into a wall or a wall outlet, and it will work perfectly fine and not be reliant on your computer. Great. So quickly going over the pins. So all of our pins are numbered. So when we are coding, we will actually be using this number scheme. There are digital pins. So ones on my or left or my, I'm not sure how you guys can see, but we will be using our digital pins. Like our analog pin can also turn on and off. All right, quickly going over our LED. So work in the event that your code does. The first thing I would recommend trying is maybe because LEDs one way, meaning you have to power the positive side, and you have to connect the negative side, the cathode, or the shorter leg, and that you are not your LED will not glow. So basically, we're going to need to make sure that our LED is positioned properly. Everything else is not really important on this slide. The only thing you guys really need to know is the anode, which is the positive, and cathode, which is the negative. All right, so coming to our breadboard, the breadboard is a little intimidating at first. However, it is not complex at all. Basically, if you look at the two sides of the breadboard, you have a red line, and a blue line. These are your powers. You actually have them on both sides of your breadboard. So your red side, which is positive labeled, basically this entire column is powered it's all lined together, so they're all powered at the same time. Same thing with your next line. However, when you go diagonally across, so your red is all positive and your blue is all negative. However, when you look in the middle, these go by rows. So these are horizontal, and we'll talk about how to use that or why that is later on. So basically A, B, C, D, E, F, G, H, I, and J are all powered together. However, if you want to connect A through E to F through J, you do have to connect them via a wire. However, for this project, we will be only using A through E. All right. Kind of getting into the good stuff. So our Arduino functions. Uh, like we discussed last week, void setup and void loop. So void setup is running the code one time, while void loop is running the code forever or until it's stopped. Pin mode, so that is actually going to be our input or output for our LED. Digital write is used to send power. Delay is actually our time slot, so how long we want to send power to something. And then tone could be in terms of frequency or duration. These are all different inputs on our Arduino. So we will actually be only using the pin mode today, because for digital, we don't have any screens, or we're not using any screens in this project. So we don't need to use our digital code, and neither do we need to use our tone code, because we do not have, we're not using a buzzer or a speaker or anything like that. All right. So getting to the software, the first thing would be to open up our Arduino software. Right. So you guys should be able to see that on my screen, hopefully. Right. So as soon as you open it, this should be your start screen, essentially. Now, you can't really code anything until we create our hardware together, or we put our hardware together and we make our device. So we can't really code anything because we don't know what we're coding, when we're coding it, how long we need to code it for, or even like where we are coding it. So let's do that first. Let's put our device together. All right, so if you guys by chance have my website, it should also be in the chat. However, if you don't, no worries. I will be trying to screen share everything on my website for this webinar. So on my website, there's actually, if you scroll down to part 2, there's a link to the project website. So if you want to find the code just like that, however, we will be walking through everything. So that's not really important right now. The main thing I want you guys to look at is the schematic. So the schematic is actually our layout of what we will be creating. So let's go to our Arduino. Now, we will start from our Arduino. We will go to the breadboard. Then on the breadboard, we will make all of our connections, whether they be power, a buzzer, analog, anything. We're going to try to do it on our breadboard. And then we will finally, excuse me, we'll finally end our schematic by returning back to the Arduino. All right. So I'm going to go ahead and open up all my cables. And the first step in any project is to come up with a plan. However, due to time in this project, I went ahead and made the schematic. So we're just going to follow along with the schematic and then go straight into the coding part. So our first step is actually going to be that we need to connect our 5-volt pin. So we're going to insert a cable into our 5-volt slot. So on our left side of the Arduino, and you're just going to push it in. And then we're going to connect one side or the other side to our positive. So positive energy is always going in. So that's what we have so far. Our next step will be connecting our LED. So like I said, our LED has 2 sides. One of them is our cathode, one of them is our anode. So we're going to be connecting our cathode in. However, before we do that, we need to make sure we have power wherever we're going to be connecting our cathode. Now, this doesn't really matter. I'm going to take off my power actually real quick. So we'll be using the A1 grid on the top. So this is a little different from the schematic. However, just to keep everything organized, so I can talk to you guys where I'm placing everything. I'm going to start from the top left corner. So A1, we're going to connect to our power and negative. So A1, and then any side in our negative we could connect to. Next goes in our LED. And we're going to connect our cathode right next to it. So A1 powers A1 powers B1, and then B2 is where we're going to put our cathode into. So that's what we have so far. Now, once we connect our power, you'll notice how we're not really using our power right now. However, that is fine. All right. Then we're going to use our resistors. So coming to resistors, yes, those are a little difficult to read at first. However, on my website, actually, I might need to refresh it. There we go. I've added this chart for you guys to read your resistor. However, I could use mine, and we're going to look at our bands. So I want you guys to try to find a blue resistor. Most of the time they will be blue. The background main color will be blue. Now, from there, you're going to read your resistor, and you're going to look at your first digit. So depending on the band color, brown. So 1. Then I have another brown, 1. Then I have 2 blues, so 11 times your blue multiplicity, so 11 times 10 to the 6th power times our tolerance, which is another brown, so by 1%. And that should get you to the resistor that we'll be using, and that is a 221 ohm resistor. So once again, that is going to be our first digit is brown, second digit is brown. Then our multiplicity is going to be 10 to the 6th power times our tolerance, which will be 1% brown. So your band colors should go as brown, brown, blue, brown. Right. So now that we have our resistor does not really matter which way we put it in. So going back to our schematic. We're going to turn our resistor over and then input our resistor. So we will put our resistor in the, so my A2 is actually crowded. So I'm going to put it into C3 now because it is still on the same row as B2. So keeping constant with your rows. All right, so once you've placed it into C3, or C2, sorry, I'm going to put the other end into C5, just to give me a little bit more space. You may need to push things in a little. Breadboards are really tight, especially if it's the first time you're using it. so you might need to push in your resistors, your LED, all your wires. All right. Our next step after we put in our resistor is going to be another cable or wire. So I'm going to get another longer one. And now we need to connect from, in my case, our resistor. So we're going to connect from our resistor back to our Arduino board. So we'll be connecting from, that is C5. So the next one over, or same row, so C6 to our ground. I'm sorry, not our ground, our digital 8. And then our last wire, we will be connecting from our negative, so the same row as my blue, negative to our ground. You may need to turn your Arduino around depending on what you used. I just had to. And it does not matter which ground port you put it into as long as it is a ground port. Right. Awesome. So now that we have our LED in, our resistor, let's make sure everything is not touching. My resistor and LED were touching, so I just had to bend them a little. We're still trying to keep them straight. Sure everything's in, not popping out. Obviously, if you have a newer breadboard, it will be more intact. All right. So I know that was a lot, but now that we have our device created, now we get to the fun stuff of coding it. Right. So the first thing you're going to do is grab your cable. So one side should be your USB, which will go into your computer. The other side is USB-B, which will connect into your Arduino. So I'm going to connect to my computer first, and then my Arduino. And you should see a lot of lights flicker. Right. So getting started, connect your Arduino to your PC. You'll see some lights flicker. All right. So I see that my Arduino is powered on. That's most important. And then I see that my ground is working. So you see a orange light for that, blinking, and a constant green light for your power. Going into our code, right? So I'm gonna click new just to make sure that I have this fresh window for writing my code. Right. So nothing really important is up there. We'll be writing everything from scratch. Right. So, but the first thing we need to do is indicate where our LED is plugged into. Okay, you're going to go into, so if you're going to tools, make sure that everything is set up. So your board, I have the Arduino Uno. you may need to change yours. Your port, make sure that it is coming in. So incoming port, perfect. And your programmer setup, that should be constant. All right. Once we finish writing our code, we will verify and compile it into our Arduino. However, the first thing we need to do is write our code. So let's get started. Now, one thing I always like to do is so I know what I'm using, so I don't have to keep looking down back at my Arduino, is on the very top of my code, I'll write down where everything is. So our backslash is actually just a note. So as you can see, put your setup code here to run once. That's a note. So we're going to do double backslash, and I will write my LED in port 8 of digital power. And that's all what we need for this one, because we'll be using one single constant flow of energy. And then we're also going to write int LED pin equals 8. This way, we don't have to keep rewriting our code as LED pin 8. And like we discussed, semicolon after every line of code, just to make sure it runs through. Now, void setup. So void setup is going to be just telling our Arduino what everything is. So for void setup, we will be doing pin mode. As you can see, the color changes. Pin mode LED pin, comma, output. You can see the color changes again, meaning it's receiving a line of code. Right. So what does this code mean real quickly? I know I went through that just writing it. So pin mode means like what we're using. So we'll be using a LED pin, and it's going to be our output. We can't really input from a LED. Something we would do an input from might be like a speaker or a light sensor or any of those devices. Right. Now going down to our void loop, this is where we'll be putting our main code. So it kind of helps you by saying setup code and main code. Okay. So our main code we'll be starting with is flash. So turning on the LED, open parentheses, 200, close parentheses, that is our power, semicolon, flash, parentheses, 200, close parentheses, semicolon, flash, parentheses, 200, close parentheses, semicolon. Right. So basically what we just wrote here are supposed to be 3 letters. So flash is SOS, because we will be coding our SOS device. Now we're going to do 2 black slashes, and that will be letting us know that that stands for S. Now, we could just enter our code here. However, nothing would turn on because we don't have time. So we don't know how long we want our Arduino to read this code. So we're going to write delay, open parentheses, and then this will be our time. So this is in terms of milliseconds. So let's go ahead and do 400 milliseconds. All right. So this is our first line of code. So what does this mean? We have we're powering on our LED at 200 intervals for 400 milliseconds. Now, since we have the first letter, we could go into our next letter, which will be O, flash, open parentheses. We're going to basically use the same line of code. We could rewrite it, however, we could just copy and paste it, however, we will be rewriting it. And the reason for that is in most lines of code, it's really easy if you just copy and paste something to mess something up. So it's easier to just go through scratch just to make sure you are understanding every single part of it. So flash, now this is a different letter. So you don't want to make it the same 200 power or else you will not be able to see the difference between your S and O. So we will be using a 500 power. And then once again, flash, open parentheses, 500, close parentheses, semicolon, flash, open parentheses, 200, close parentheses, semicolon. A question I would constantly get is do you have to write flash multiple times? For example, I'm running it 3 times. No. However, one benefit of writing things multiple times in the same line of code is it just allows you to kind of differentiate between, or easily differentiate between your code for different devices or what you're doing. So this is a device, then a single line is, or a single word is time. We know it's a device again. The next one will be times, will be another single word. Now 2 backslashes, just to write a note, this will be standing for O. So 500 power will be an O. And then delay, so that how long we want it to stay for, delay. We could do any time. Let's do 400 again. Or actually, let's do 700. So it's 7 seconds to differentiate between our S and O. Great. Last line of code. So we're going to rewrite our S code. So that will be flash, open parentheses, 200, close parentheses, semicolon, space, flash, open parentheses, 200, close parentheses, semicolon, flash, open parentheses, 200, close parentheses, semicolon, so that's S, and then delay, we'll write that for 400 again. Now, basically what I just did there is I literally recopied my S code because we'll be using the same letter, so SOS. So we wanted to make sure it was the same code. Just so as you could read it, you might be able to read it even without the notes. However, if you're coding and then sending the file to someone else, it's definitely helpful for them to easily read what's going on, especially if there's a problem, we could easily troubleshoot. All right. So that's it for our main code. So now the last thing we need to add actually will be our void flash. So in other words, what happens if our flash does not work? So flash, open parentheses, int, initiate the duration. So how long we want to wait. or what happens. We're going to write our third line of code, and that will be open brackets again, and then it automatically inserted our close brackets. That's one thing we don't have to worry about in Arduino. However, in Robots C, you might need to add that. All right, so we're going to write digital write. So digital write means what pin we're using. So we're using our 8th pin, but we already indicated that on the top. So we're going to do LED pin, and then we're going to want high power. Our high power is going to be designated as 500. And then we're going to write delay. And then we're going to write duration. So this is basically telling us, or is a summary of what all of our code is. So digital write is we're going to have our LED. Delay, we know it's going to be our time. So these are essentially just notes. So then we're going to write digital write again. LED pin. Now we have high power, so we also have low power. Close parentheses. And finally, delay, parentheses, duration, close parentheses, semicolon. All right. So that's actually it, or all of our code for this project. So let's go through it real quickly. So we're indicating our pin or what it is. Then we have our main setup. So in a pin, we're going to have an output, or at pin 8, we're going to have an output. Then for S, that will be a power of 200 for 400 milliseconds. Then for O, we have a power of 500 for 700 milliseconds. And then for flash, or our third line, or our second S, so SOS, power 200 for 400 milliseconds. And then the void flash, we're going to end up writing our code. So digital write, LED pin high. So for high power, we wrote a duration. And for low power, we also wrote a duration. All right. So now, since we have our code, we're actually ready to test it. So we're going to go to Sketch, verify and compile. So this is going to ask us to save our code. I will call this SOS and save. Okay. So one thing about Arduino, it does tell us any errors we have. So we see I forget, did I write something before that? Oh, I got my semicolon there. Yes, so it also guides you. I forgot my semicolon, so expected semicolon before digital write. Verify file. There we go. This time no issues. And space, that's fine. It's fine. Okay, done compiling. And then it should download. to our Arduino. Arduino. It should be my Arduino Uno. I'm not sure why it's not reading it. Oh, because I have a loose cable. There we go. Make sure everything's intact. Right, and there we go. So now we have a S. Now we have a O. Now we have the S reading it. And it's going to keep going until since we did not end the loop. So it will keep going through the SOS phase. Right. Okay, so that was it essentially for our code. I know it's kind of hard to understand over digital, especially, or just learning from the computer because it's not hands-on. However, I am here to help you guys learn. So in the event that you didn't understand or see the entire code, I do encourage you this was the entire code that we wrote. And then also if you go to the website and then click the project file, I think, or something like that, it will take you to the actual code itself, and you could download the code from there. However, I do want you guys to try learning the code. So try doing it, try compiling and downloading it. I could actually see right here, I forgot to write semicolon. So make sure you didn't forget semicolon. And when you do compile and download, it will check for any errors. So look through your errors, actually read them. They are there to help you. So we do have some time, so let's not do that just yet. So I will be opening up the chat for any questions that you guys have. Oh, I'm sorry, but I just saw this. You do not need the kit to participate. Obviously, if you want to try it on your own, just like I did, then it would be helpful to have the kit. So what does the resistor do? The resistor basically helps clear up the power, or it lowers the amount of power you have so you don't burn your LED. LEDs are actually super fragile. So you can't take it. If you take a LED and connect it to a 9-volt battery, you will end up burning your LED. No, it's not going to explode, but it will just shine really brightly, and then that's it. What is the last flash in the second line of code 200? The last flash. Okay, so the last flash is once again just to help me know what's going on. It just differentiates between your time and your letters. With the space between the delay and 700 cause the code not work. Delay and 700, no. So luckily, Arduino does not read spaces, so you could have as many spaces as you want. You could probably do tab and insert spaces that way. it would not affect your, or it should not affect your code. What can we expect in part 3? So in part 3, you can expect a more complex project. This one was using a simple output device, which was the LED. However, in part 3, you could expect more of a input device. So I haven't finalized what project I want to do yet, but I'm leaning towards a light amplifier, other known as like using a photo. I think I have one here. So a light indicator essentially, and then if there's more light, then your LED will not turn on. But however, if you decrease the intensity of light in the room or the atmosphere or environment, your LED will turn on. So kind of like a night light, which is self-adjusting. What would happen if I had a resistor with different colors? Your intensity of your light will be different. You can actually code this without a resistor. However, I like to use a resistor just to make sure that I'm not, I don't have the potential of burning my LED. So theoretically, I could code other words or phrase it instead of SOS with the basic Arduino kit. Yes, of course, you can code anything. However, like I said, your LED is not going to show you letters like SOS. However, it's basically Morse code. So your duration, you could code for different letters. Your duration and time. Doesn't matter where on the breadboard I connect things. Yes, so in our breadboard, we have a single line of code or a single line of energy going through. So we have power going in that goes through our resistor into our LED. So it has to pass through the resistor first so that our LED does not burn. Then it goes back into the Arduino port for a ground. Do other coding softwares read spaces or no? Some read spaces, some don't. It just depends on what you're using. Robot C does not. Robot C for Vex does not read spaces. Robot C for Vex does read. Yeah, Robot C for Vex does not read spaces. Robot C for Lego Mindstorms does read spaces. Right. Any more questions? Right, so we still have a little bit of time, 12 minutes. I guess I could wait for a few more questions for the next 2 minutes. Why did he set the power to 500 for O? I set the power for 500 just because I want a different power for the O compared to the S letter. So I had two things that made O different from S, just so I know that they're different signals. So one was the intensity of the light, so 500 power, and the other was the time. Could you use any other number? Yes, you could use any other number. Code is very open source, so if I wanted, I could turn any time into a higher number. However, for my flash or intensity of my LED, I would probably not want to go over 1,000 max because I don't want to burn my LED. However, if you wanted, you could go super low on your power as well and just take out your resistor altogether. We will be learning to code 2 things at once. No, since these are only 1-hour sessions, we'll only be coding one thing at a time. Where did you get all your materials like the breadboard and transistors? So I think you meant resistors, but everything came from, I think I bought it off of Amazon. This was 3 or 4 years ago, I think. But this was the Arduino kit workshop. However, the kit that I have on my website has all the same things in this kit. It just has a different name. If you added more LEDs and coded for it, could you spell something with the LEDs? Could you add more LEDs? Yes, you can definitely add more LEDs. So in the code, I had initially stated INT LED pin. Let me see if there's a way I could take this chat out. Okay. Unfortunately, I can't dual screen, so I can't show the chat or see the chat and show the code at the same time. However, you could definitely add more LEDs. You would just have to insert a different code. So in the first line, we wrote INT LED pin equals 8. If you added another LED, it would be another LED pin equals maybe 6 or 7. One thing you might want to do though is to differentiate between your LEDs, write the backslashes after 8, and then maybe that's your green LED or your first LED, and then your second LED writes your red LED or something else. So if you did void setup here instead of void glue, SOS would appear once, right? Yes, that is correct. If you were to design a program that accepts input from the environment, such as sound, which software would you use? Or is it a combination of software? You could actually do that on the Arduino. Arduino is very open source and flexible, but the only thing with Arduino is that it depends on what you're using or attaching to it. In this case, we connected the LED and resistor. However, you could connect a buzzer or any other input or output device that is compatible. Most are compatible with Arduino. Can you set up the time the light stays on and then the amount of time in between each flash? Yes. So we did do that when we wrote delay. Delay is our time variable. So that tells us how long we want our LED to stay on. I am not able to connect my Arduino to my computer port. Do you know how to fix this? There are many things that could be that. If you connected your Arduino already, one thing I would always check for is make sure that all your connections are super tight, making sure all your wires in your breadboard are down, your LED is plugged in correctly. On your breadboard, you should hear like a click just to make sure that everything is plugged in super tight. But then on the platform side or Arduino side, on a Mac, if you go to tools, make sure your board is selected correctly, and then also make sure your port is selected as your Arduino Uno USB, because we don't, or at least I'm not using a Bluetooth Arduino. So for me, it was to make sure that it was connected via USB. What's a breadboard? Breadboard is basically this big thing that we used here. Basically, it allows us to make connect many things onto our connect to our Arduino. However, our Arduino is kept simple, while our breadboard has the nice big mess of wires. One thing I actually do want to know is that on the Arduino, you do have, I believe, 2 LEDs that you could code. You don't have it on the Arduino Uno, but on the it's one of the bigger Arduinos. It was the Arduino Mega. So if you have the Arduino Mega, you actually have an LED port right on there that you can use. Could you use a different language of code with an Arduino, such as Python? No, you cannot use Python with Arduino. Are there any other kinds of hardware than the Arduino? Yes. However, that would just be going to a different programming method, such as Robot C. I personally like Robot C more than Arduino. However, Arduino is more it's a bit higher up than Robot C, for me at least. So that would just be using a different coding platform. Any more last minute questions? What do you think is the easiest coding system to work with? Well, the first coding system I actually learned was Robot C. So for me, that was the easiest just because I had learned it first. However, I guess it just depends on what you are trying to accomplish. Different coding systems are used for different reasons. What do you think is the easiest coding system to work with? Or what's the difference between Arduino and Robot C? There's not much of a difference, to be honest. I guess the main difference is Robot C is everything for the in Robot C. Everything, all the lines of code are in a single row, while in while in Arduino you use multiple lines. Is this the kind of work you were assigned in college, or is it more complex? This is kind of what I started a little bit in college. However, when we do get to a lot more complex stuff, usually it's already coded for us. I don't focus on a lot of coding in college now, though, because I am a biochem major, not a computer science major. However, I do have friends who are computer science majors, and they're doing a lot of intensive coding. Have you ever used or learned Python? No, I do not have direct experience with Python. So I can't really say if it was complex or easy. Yeah. I personally code for class? Not in this year. This semester, I don't have any classes for coding. What do you mean by intense coding? Intense coding basically mean a lot more input. So like, for example, today we only had that one LED. However, for example, next week we're gonna have both a input and an output. But then like super intense, you could get into like 10 different LEDs that you have. I have a robot somewhere in my closet. That has four motors in it, and one claw motor. I was gonna just go and grab it. However, I'm not exactly sure where it is. All right. So I guess we'll wrap it up. If you guys come up with any more questions, feel free to contact me. I'll try to get out my robot for next week, just so I could, I guess, answer your questions with a physical item in my hand as well. Right. I will see you guys in the next one. Bye.